Okay, hello, good morning everybody. Again, so Nick Bolan, Mill Space Capability Lead. I will get you 5 minutes closer to lunch by not introducing myself or giving you my bio again, but rather just dive straight into the content of what I'd like to talk about today. So specifically, this is around strategies for optimizing resilience. And firstly, this is clearly a really important topic. We've already had one topic or one brief on this earlier today from Luke, which I think was a fantastic scene setter for what I'm about to go into, and I think you will hopefully see some strong synergy between the topic. So why specifically is this of interest? So I think professionally, absolutely, from a Mill Satcom, Mill Space perspective, it is clearly extremely relevant today. And this question of how best we might achieve the highest levels of military assurance to meet and defeat the future threat landscape, this is a really, really significant challenge for today. But also from an implementation perspective, so how we might go about identifying strategies that enable you to embrace the principles of own access and collaborate, and harness the power of new space and international collaboration to make resilience and affordable reality is really what we're trying to get after here. But also from an operational perspective and a personal perspective, this is a topic which is extremely close to my own heart. So as an engineer, I think there are some really fundamental key questions that need to be unpicked around this. First and foremost is this idea of how do you actually make this usable? How do you fuse all of these factors together in such a way that delivers benefits to the end operational user in a seamless rather than a siloed manner, such that disparate network capabilities can operate as a single unified capability that provides unmatched resilience in the face of a rapidly changing threat landscape and allows the operator to be focused on the mission at hand rather than fighting the comm system and trying to get things to work when they are denied or degraded. So this is a really significant, enormous challenge that we face today, and something that I would like to share some specific thoughts around. So the first point is, what do we actually mean when we talk about resilience? It's this buzzword that is mentioned a great deal, but what do we actually mean by this? How do we achieve this today? What are the limitations and constraints that we need to be cognizant of, which may be presenting or preventing us from achieving better things in the future? And then from that future perspective, what are the things that we need to be thinking around to achieve this level of functional resilience? So I think before we dive into the specifics of resilience, it is important to note that this is one of a number of capability strands that we need to consider when we're thinking around future MilSatCom capability. So I and a number of others have given this a great deal of thought over the years, and we've come up with this snappy mnemonic of C5 MARSIDs: capacity, coverage, concurrency, control, connectivity, mobility, availability, resilience, survivability, interoperability, space domain awareness, and security. The point here is resilience needs to be thought of holistically and in the context as part of a much wider set of capabilities, such as capacity. So this need for ever greater data throughput to disadvantaged users. Coverage, this increasing need to support multiple concurrent operations within either the same or disparate geographic locations via either single or multiple systems. But also mobility, the need for users and user capabilities to be much more dynamic in the way that they move across the operating environment and ensure greater freedom of movement to seamlessly roam between otherwise disparate systems. And so on and so on and so on. I won't go cover each one of these in depth, but you get the idea. Ultimately, that this is a complex array of user requirements that need to be engineered and integrated as an overarching capability, but it is also a problem space which is rapidly changing through time. And when we think around how conflicts that have been delivered in the past have been executed and delivered, we need to recognize that potentially, looking to the future, we need to think differently about how we employ technology. So where does the idea of resilience fit in specifically? I think that to address this in the first instance, you have to start by thinking a little bit more about threats, which has been touched on earlier today as well. So I'm sure you are probably familiar with this graphic. So this is the MOD mod counter space continuum that was released a couple of years ago. And as we look from left to right, Today, we know that potential aggressors and adversaries have access to and the ability to implement some, if not all, of the kinetic and non-kinetic effects which are defined here. And I dare say that there are also plenty of other things which are being developed and defined which are not on this slide today, which are likely to emerge in the near future. So what? So what is the big question that we need to take away from this? And I think certainly a key question is, what is at the heart of the problem that we are trying to solve here for the user community? Is it to engineer and develop bespoke solutions which provide explicit mitigation to the specific threats that we are showing? Or do we need to be thinking more holistically and think around how we develop technical solutions which really get to the heart of this idea of how we hardwire or perhaps leverage sovereign, allied, and commercial SATCOM systems and create resilience at the network layer as an absolute mitigation to a highly dynamic and uncertain threat environment. Okay, so resilience itself, I've talked about it a lot, it's been mentioned already today. What do we actually mean though? I would advocate that there's this idea of 4 R's: reliability, robustness, redundancy, and reconstitution. So at the nodal subset of the system layer, reliability is about how well your things in your system perform under uncontested conditions. Robustness, how well those same things perform in contested conditions. Redundancy, how many nodes do you actually have within the system? But fundamentally, reconstitution, what is your ability at the network layer to dynamically switch between all of these different nodes in a seamless manner? So, aligned to this definition, how do we solve the problem or address the challenge of resilience today? So, fundamentally, I would suggest that there is no single approach which exists which appropriately mitigates the problem space today. So, this process of assuring today's capabilities are, I would argue, focused on making individual components in the satellite system, in the satellite network, much more robust. So we employ ComSec and TransSec to mitigate against cyber and jamming activity today. We might consider the trade space around chemical versus electrical propulsion systems when we're thinking around how to address co-orbital anti-satellite capability. It's important to stress that I'm not for a second suggesting that any one of these approaches is incorrect, but I refer back to one of my original comments and suggest that this may not get to the heart of the fundamental problem around how we best hardwire or leverage sovereign, allied, commercial satellite systems. I also think it is very important to highlight that this method of targeted threat mitigation comes with a very heavy systems engineering overhead. We also need to recognize that the more precise the solution to a threat, the less potential for transferability or crossover to other threat vectors. So if we go back to our 4Rs model for a second with this in mind and specifically think around how we extrapolate that model and look at it through time and begin to understand where specific technical themes sit relative to the idea of reliability, robustness, redundancy, and reconstitution. There are lots of technologies that exist in this landscape, some which were really well covered off this morning. But just as a start of a 10 to sort of provoke the discussion, we've got things like chemical propulsion systems, anti-jamming, satellite, space domain awareness, bodyguard satellites, in-satellite links, onboard processing, regenerative processing, multi-band constellation, vendor disaggregation, software-defined wide area networking, and so on. I think when we look at this, a number of key observations really come to mind. So the first observation is around depth of integration, around where these sorts of capabilities sit within the network layer or OSI model. So in the bottom left, this is really physical layer, or I would even potentially argue mechanical layer capability in some instances. But as we move out over to the top right, really we're getting further down or further higher up, depending on your perspective, into the OSI stack. So that's observation number one, is that achieving seamless network layer reconstitution requires integration in the lower levels of the network stack. We need to be thinking a little bit more beyond just bare layer connectivity. The second observation is around physical location of where you integrate. Do you do this in space or on the ground? So if you integrate in space, is this done through in-satellite links in order to achieve interconnectivity between MILSATCOM and ISR capability, or between LEO and MEO geo service providers? So this may achieve physical layer connectivity between systems, but does it really ensure seamless and secure traffic flow between systems? Or do you do this on the ground? If it is on the ground, do you do it at the terminal level, where you might save some physical real estate on the deck of a ship or on a deployed operating base through using multi-band, multi-orbit terminals? But what does this achieve in terms of achieving resilience as a seamless and dynamic network layer traffic capability? What if we were to integrate out the baseband or the IP network layer? So this means potentially that we don't perhaps need to treat this whole problem space as a VHS versus a Betamax standards-based problem, and potentially risk generating a problem around vendor lock-in, but perhaps rather think about how integration at the baseband offers a means of preventing vendor lock-in in order to achieve actual network layer reconstitution. So why don't we do this today? And what are the limiting factors that we need to be aware of, which we need to design for if we are going to achieve seamless dynamic network layer resilience in the future? Well, one key factor is encryption. So today, the MOD's network architecture that joins the fixed and deployed space is characterized by this model of red and black networks. And whilst today it is possible to procure services from new and slightly less new military and commercial LEO and MEO service operators that bring definite technical benefits and elements of commercial freedom, the way in which encryption is employed today prevents full optimization of these networks. So what do I mean? Specifically, I see this as an end-to-end supply and demand problem, which is about marrying up end-user traffic needs, the demand. So that is the ability to move different types of network services, voice and video and data, at different security classifications in a seamless manner, given the availability of bearers, the supply that is made available. So that is all very well and good, but today the way that encryption is employed means that the performance metrics, so latency loss and jitter of these different new network providers and services, cannot be shared with or used to align with the service priority of end users. Another constraint of this approach is the way in which it dictates a single bearer per security domain architecture, such that if one single bearer is denied or degraded, then all users that are hosted on the security domain are directly impacted. And it's probably just worth reflecting on that for a moment to consider the operational implications of that in terms of if you have a disparate user community based over a large geographic area, all hanging off a single security domain. Minor disruption or degradation of that service has a significant operational impact. So if we go back to our bird's eye view of today, so what is it that we are really trying to achieve? Is it to wrap each available bearer in as much physical protection or layers of protection as possible to ensure that they will never go down or never be denied or degraded? Or is it to really look at this as an end-to-end traffic engineering problem and consider that whilst I would suggest that military systems definitely have higher levels of assurance than commercial systems, what is required is an approach that ensures that when networks are denied or degraded, traffic is able to seamlessly and dynamically reroute across alternate bearers of opportunity in a totally seamless manner, which is totally agnostic to the end user. So to wrap up, hopefully this has been a useful insight into some of the ideas that we're considering around how you actually get after this problem of optimizing resilience for the end user. I'll just go back to one of my opening comments around usability and really emphasize this point that when we're thinking around how we need to engineer solutions to this problem space, we absolutely cannot afford to lose sight of the benefits that solutions we're developing bring to the end user. And perhaps we need to consider that rather adversely, the best solution to this problem space is likely to be the one that is completely invisible to the end user. It is one which will totally enable seamless traffic roaming between bearers in a highly dynamic and real-time manner. And to reiterate, that is not to say that integrating in space or at the terminal doesn't bring benefit, absolutely not. But I think what's really key here is about recognizing which point of integration offers the biggest benefits potentially quickest, and how do you leverage that to avoid some sort of standards Betamax versus VHS vendor lock-in problem. So what are we actually doing to solve this problem? Clearly, I wouldn't be standing here if we weren't seriously looking at this problem space, or indeed if we didn't have things in the pipeline which we're working to develop to address these sorts of challenges. What I would say is, if you want to know a little bit more about this, come and please do speak to myself directly, or the Airbus team sat on the Airbus table over there. We will be happy to engage further on some of the development work that we're doing around this. I will wrap up there. Happy to take any questions.
Hello. We can afford 2 questions, okay. Nick. So has anybody in the audience got questions for Nick? Oh.
Okay. Just to ask, from what you said of the 4 R's, and you presented, are you therefore saying we need to add an S for separacy?
Separacy? Sorry, what would you mean by that? I don't know.
So you have got alternative paths that don't go down at the same time because all the eggs are not in one basket. Diversity was an earlier word, but the problem I discovered years ago is diversity could mean you've got fibers in the same duct. Different fibers, but the same duct. So separacy, you've got physical separacy of path. So
I will do a classic conference thing and not give you a very pointed answer, but I think you raise a really interesting point. What I would say, in terms of the core architectural approach that we are considering around this problem space, and to sort of labor on this idea of where do you integrate, and this idea of, different points of integration all have different benefits, but they all have constraints and challenges as well. I think on that idea of separacy, I would look at that more in terms of, there are definite users who will benefit from having integrated terminals and bringing all of that capability and infrastructure together in a close-knit environment. And perhaps in those instances, this idea of separacy and some of the challenges that may present from a security point of view need to be fully considered. But I would also say, I think in terms of creating that resilience through disaggregation from an operational perspective, again, it's more of an argument to sort of say, actually, the more you can not be dependent upon a single terminal and have a distributed ground segment architecture which is able to do that data fusion but dependent upon different terminals that are geographically dispersed, actually further enhances your operational posture as well. Yes. Yeah.
We can take one more question.
Lawrence Russell, Data Center Dynamics. So you mentioned satellite co-orbiting a little bit earlier on, which is something that's been spoken about a few times in military satellite shows. I would love to hear a little bit more color on what is happening there. We've heard some speculation that some people think that they're tuning into some of the same frequencies, suggestions that they're just practicing for the ability to do this for some capability that we might find out more about later. I would love to hear what you might speculate is occurring when a satellite co-orbits another.
So I would be the first to flag, I can't speak on behalf of the MOD in terms of what their threat profile looks like around that. I would certainly point you towards Dave Black, there he is, and other people in uniform who are sort of more at the coalface of that. But clearly we do have a view. I think in terms of what's available in the open media, we are, from an industry perspective, we do a lot of background analysis and use case development to understand how things that are available in the open source could translate into future requirements, and what that means in terms of the sort of ConOps that we need to be thinking around for all manner of spacecraft. So all different orbits. I alluded to it in terms of the sort of propulsion systems. I think when you get into this discussion, it can very quickly sort of turn into a debate of, well, is it chemical versus electrical? again, everything has its trade-offs, and it really depends on the specifics of the capability. A very generic answer. I'd say if you do want to know some more, let's perhaps have a separate chat. Yeah.